In this video, we are going to look at ripple tank experiments for reflection and refraction. So for reflection of water wave, let's say there is a ripple tank in which we have got a barrier. A wave travels towards the right, it hits the barrier and it will get reflected. So when we complete the ray diagram, we can see that we have drawn a normal which is making 90 degree with the barrier. The ray which is initially falling on the barrier is called as incident wave, and the wave which bounces back is called as reflected wave. Now we can also label the angle as I and R. According to law of reflection, I is always equal to R, where I is the angle of incidence and R is the angle of reflection. Next, we can look at refraction of water wave. So let's say we have got a ripple tank with two different depths. One side you have shallow water, that means less deep, and the other side you have deep water, that means more deep, the depth is more. So when the wave travels from the shallow water to the deep water, it will bend as shown in the diagram, and the one which was traveling towards the boundary is called as incident wave, and the one which is in the deep water, because it's refracted, we call it as refracted wave. We can see that it is bending and not going in straight line. In shallow water, we need to remember the speed of water wave will be less, whereas in deep water it travels faster. In deep water, water travels faster. So if the speed is less, obviously the distance covered will also be less. Therefore, the wavelength is less in the shallow water. In deep water, the speed is more, so the distance covered will be more, so the wavelength is more. But remember, frequency stays constant. It does not change. So in refraction, speed and wavelength will change, but frequency will stay constant.